Hi, in this video we are going to see what is machine learning, the definition of machine learning and simple simple learning process and some of the examples of machine learning. Now first of all we'll see the definition of machine learning. What is machine learning? Machine learning is it enables machines to automatically learn from the data, improve the performance from an experience, and predict the things without explicit programming. So simply it is called as a machine learning. So it enables the machine to automatically learn from the data, improve the performance from an experience, and predict the things without explicit programmed. Now for any machine learning programming, the data is very important. The data is very important. So here for the machine learning algorithm, we are providing some training data. The training data contains features and corresponding class labels. Features and corresponding class labels. Okay, we are providing features and corresponding class labels. Based on this data, the machine learning learns some information from the training data. So from this, we are going to the machine going to generate one model. That model is called as a mathematical model. So here the features are called as a represented in the form of x, and the class label is represented in the form of y. So now we are defining some mathematical function between the features and corresponding output label, class label y. So here this is simply called as a mathematical model. So from this one we are going to generate whenever we are giving the features for your model, automatically we are going to generate the corresponding class label. So simply this is called as a machine learning. So we'll see that the two different ways of machine learning, two different types of modeling, like one is traditional modeling and machine learning modeling. First we'll see what is the traditional modeling. For example, in the traditional programming like C, C++, Java, whatever may be. So in this one, suppose if you want to develop one model, like suppose I want to perform an application, develop one model in order for addition of two numbers. For example, I want to perform C equal to A plus B. In this one, the data is required is A and B. So here the data is provided as A and B, and we are developing one model. That model contains the entire program of the corresponding model, like we are writing the C equal to A plus B. C equal to A plus B. Now our model, our computer, in the computer it takes the data and as well as our model. So based on this data and corresponding model, the computer generates the output. Suppose if you are giving the A equal to 5 and B equal to 6, the corresponding model is going to executed. The corresponding result is given as a 11 as output. So this is called as a traditional modeling. So we'll see the other way, that is called as a machine learning. In the machine learning, here the data is very important. The data is very important. For example, it can for example, iris data set is there. Iris flower data set. Okay, it contains flowers like flowers. Iris flowers is there. So it contains different features are there, like sepal length, sepal width, petal length, and petal width, and corresponding class label sepal length, sepal width, petal length, petal width, and corresponding class label. So here it contains 150 instances are there. Okay, now here the class labels are in the form of Setosa, versicolor, and virginica. Like that, we are having different class labels. So now here, for the machine learning, for the computer, we have to provide some features like here sepal length and sepal width and petal length are called as a features, and class label is called as a corresponding target variable or expected output. Okay, target variable. Okay. Now, for the computer, we have to provide some input data in the form of features and corresponding class label we have to provide. Class label is called as output of the model. Okay. Now, based on this data, the computer going to learn based on this input data and corresponding class label. The machine is going to learn the things. So based on this one, we are going to generate one model. The machine is going to generate one model. That model is, for example, f is a function that gives the relation between the x to y. So this is a one model that is going to generate between the corresponding sample data and corresponding results. Okay. So now based on this model, for this model, once again we have to give the for this model. Now we are giving some new data to the model. That means we have to provide the only features to the corresponding feature of flowers, like sepal length, sepal width, petal length. Petal width you have to provide to the corresponding computer. Based on this model, our model is going to predict the new thing, the corresponding class label of the output, class label. Okay, simply this is called as a machine learning. Okay, so here the first of all the computer is going to learn from the training data, and based on the training data we are generating one model. Okay, for this model we are going to give the new input. So our model is going to generate the corresponding class label or predict the new output. So this is called as a machine learning. So in simple words, we fed the training data to the machine learning algorithm. This algorithm will produce a mathematical model, and with the help of this mathematical model, the machine will make a prediction, undertake a decision without being explicit programming. Simply this is called as a machine learning. So during the training data, the more machine will work with it. Okay, then the more it will get the experience, and the more efficient result is going to produce. Suppose if we are going more training on the data, automatically we will get the better output. So simply it is called as a machine learning. So for example, in the driverless car, the training data is fed to algorithm like how to drive a car on the highways, busy and narrow street with factors like speed limit, parking, and stops at signals. Okay, stops at signals. After that, you are developing a logical and mathematical model is created on the basis of that, and after that the car will work according to the logical model. So also the more the data is fed to the more efficient output is going to be produced. So we can see we'll see other definition of the machine learning. Here a computer program is said to be learn from the experience E with respect to some class of T, task T, and performance measure P. If it performs at the task in T as measured by P, and improves with the experience. So here experience is the experience task, and performance measures are very important. Now To have a well-defined learning problem, three features need to be identified. So the first one is the class of task, the measure of performance to be improved, and the source of experience. So first of all, now we'll see other thing is that is a simple learning process. For any learning system, we must know the three elements. So the first one is the task T, and performance measures P, and training experience E. At high level, the process of learning system is like this figure. So here the target, the unknown target function is there. That is, it establishes some relation between the features and corresponding class label, corresponding target variable or class label. Okay, so features are called as X and corresponding class label Y. Now we are mapping that unknown target function. Our aim is unknown target function. F is a function that gives the X implies Y. Now from this one we are mapping some relation between the each and every feature and corresponding class label. So here X1 is mapped with corresponding class label Y1, X2 is mapped with corresponding Y2, and so on until all the training examples are mapped with the corresponding class label. Now based on this one we are mapping some function between the input variables and corresponding class label, that is features with the corresponding class label. Now based on this one we are generating one model. The computer is going to generate one algorithm. Okay, one model. So for this model we are going to give some hypothesis test, hypothesis set. Now that model is going to give the final hypothesis F equal to G. Okay, now this is called as a simple learning process. Okay, the learning process starts with task T. The learning process starts with task T, performance measure P, and the training experience E. Objective are to find out unknown target function. Our objective is to find an unknown target function. So the target function is an exact knowledge to be learned from the training experience, and it's unknown. Okay, so for example, in case of credit card approval, the learning system will have the customer application records as an experience, and task would be classify whether the given customer application is eligible for a loan or not. So in this case, the training examples can be represented as X1 and corresponding Y1, X2 and corresponding Y2, and so on, Xn and corresponding Yn. Okay, where X represents the customer application details and Y represents the corresponding status of the credit approval or not. Okay, so with these details, what is the exact knowledge to be learned from the training experience? So the target function to be learned in the credit card approval system is mapping function F equal X implies Y. Now this function represents the exact knowledge, define the relationship between the input variable and corresponding output variable. So F is a function that gives the X implies Y. So we are providing some relation between the corresponding input variable and corresponding output variable. So the learning algorithms try to guess a hypothesis function h of X that approximate the unknown function. Our aim is to approximate an unknown function. So a hypothesis is a function that best describes the target and the hypothesis set or space of hypothesis is collection of all the possible legal hypotheses. So this is the set from which is the machine learning algorithm would determine the best possible, which would be best describe the target function or the outputs. The goal of the machine learning process is to find the best final hypothesis that best approximate the unknown target function. That is the main aim of the learning process. We have to find the best final hypothesis that best approximate the unknown target function. So we'll see some of the examples of the machine learning. So the first example is a checkers game. First one is a checkers game. Here, the checkers game, a computer program that learns to play a checkers might improve its performance as measured by its ability to win the class of tasks involved in the playing checkers game through the experience obtained by the playing games against itself. And the checkers learning problem contains three things. One is task T. So playing the checkers is the task of the checkers game, and performance measure P is percentage of games won against the opponents is called as a performance measure P. The training experience is E is nothing but a playing practice games against itself is called as a training experience E. Now we will see one more example. Handwritten recognized learning problem. So here a set of data set is there. It contains a set of handwritten digits. Now the task T is recognizing and classifying handwritten words within the images. That is our task. And performance measure P is percentage of words correctly classified. That is called as a performance measure P. And training experience E. So a database of handwritten words within the given classification is called as a training experience. We will see one more example, that is a robot driving learning problem. So here the task is driving on the public 4-lane highway using the vision sensors. So that means you have to travel from one source to destination with the help of a vision sensor. So simply it is called as a robot driving car. Okay. Now the performance of measure P is average distance traveled before an error. So simply it is called as a performance measure. Without any obstacles, without any error, how much distance is traveled is called as a performance measure. And training experience E is called as a sequence of images and steering commands recorded while observing a human driver. So these are the experience E. So this is about the machine learning. Okay. Now we'll see how that is going to evaluated, how the machine learning problem is going to executed. So first of all, any machine learning algorithm, problem, first of all you have to collect the data. So now the data is given to our machine. For example, here the for example, iris data set is there. So this iris data set is given for our machine. So it contains the different types of features are there, like sepal length, sepal width, petal length, petal width, like that. These are the features, and corresponding class labels are there. So for our machine algorithm, we have to provide the corresponding features and corresponding y you have to provide. So this is called simply training data. Now based on this training data, okay, we are going to train our machine learning algorithm. Okay, we are training our machine learning model. So after that, okay, our model is going to ready. So for this model, we have to give the new input, like new sepal length, new sepal width, okay, petal length, petal width are going to give. Automatically the ML algorithm going to predict the corresponding class label, whether it is a setosa or versicolor, okay, or virginica, like that. It will be predict the things based on the new input data. So this process is, if it is correctly classified, then we are going to stop the process successfully. Okay. Otherwise, if the wrongly classified the corresponding class label, then once again we are going to train our model with based on different types of algorithms. Okay, then based on the different models. Okay. Okay, now we are generating a new model. For this new model, once again we are giving the new input data, and that model is going to predict the corresponding output. Okay, so this process is continued until you find the better correct classification algorithm. Okay, this process is called as a machine learning. Okay, thank you for watching our video. Thank you. In the next video, we are going to see what are the different examples of the machine learning. Why are we using the machine learning? Thank you.